All right, so we're going to look at another relatively simple sorting algorithm. This is called insertion sort. And insertion sort, we are going to insert a card into the correct position every time we come across a card. Now, this is already sorted, so let's mix it up so we have something fun to work with. All right. And here is our insertion. Well, that's a little bit not random enough, so let's just mix it a little bit more. That's a little bit better. Okay. So recall that when we talked about selection sort, our goal was to go find the card that needed to be in this index. Insertion sort works a little bit differently. Instead, what we do is we go card by card and just put it in the right position given what we already know. So we're going to kind of progress through, and as we progress, everything that we have to our left is going to be sorted. But as we add a new card to our list, we're going to go and insert that into the position that it needs to be. So we start here. We say, well, I have 6. 6 is by itself, so therefore it's sorted, so I can move on. Then we go and we look at 2. We say, well, that's not in the right position because it's lower than the thing to its left. So we are going to pick it up and start moving it down until we find the right position. This happens to be the right position, so we do a swap, put the 2 down. I've now inserted it in the right position, and these 2 are now in the right position. Move up to the next card. It just so happens that 8 is in the right position. I don't need to do any insertion, so now this part of the list is sorted. Move to the next card. Well, 4 is smaller than 8, so I'm going to move it up and find a spot for it. And as we slide down, move these over actually, so I have a little bit more room to work with. As we slide down, we say, hey, it needs to be inserted right here. So 8 moves over, 6 moves over, 4 moves down. And we continue. We say 5 is less than 8, so we pull it up, find out where it needs to live. Here we go, between 4 and 6, so then 8 has to move over, 6 moves over, 5 gets inserted to the right position. So as you see, as we go along, these cards are always going to be in order. The ones that are left are not. But we're not going and finding the smallest thing first, like selection sort, and putting it into the right position. These cards may have to move their indexes. So even though this part of the list is sorted, the final position of these values may still change. So as this insertion sort goes, we also might have to move things a lot more. Let's take a look at this next card. I go and I take the 3, and I say, well, let's see, that's smaller than an 8, smaller than a 6, smaller than a 5, smaller than a 4. So in order to insert it here, I have to move all 4 of these values over. That's a lot of movement of data just so that I can insert one card. Now, the flip side though is when I get to the 7, 9, and 10 at the end, I go and I check this 8, I find out I need to insert right here, I move the 8 one time, and then the 9 and 10 are already in their positions, they don't need to be moved at all. So insertion sort is nice when things are already in semi-sorted order because I don't have to look through the entire deck all the time. In fact, if I have a run, so for example, if I got to this point, let's see, if I got to this point and I moved and put the 5 in, and then I started checking, I could actually just put all of these right in order. I don't have to look through the entire deck. So whereas selection sort, I always look across the entire deck, find the smallest value, and put it in place. In insertion sort, I can end up doing a lot less comparisons because as long as I'm bigger than the thing on the end, I don't need to look all the way back. However, if I have the unfortunate situation where one of my last cards is a low card, then not only do I have to do a lot of comparisons, but I also have to move a lot of values in order to get this card into its right spot. So selection sort and insertion sort have a trade-off in that value. Insertion sort does a lot more movement of data. Selection sort does a lot more comparison of data. All right, hope that helped make sense. And let's take a look at another sorting algorithm.